Welcome to the AWS SaaS Lab session on microservice design and decomposition in the SaaS context. I am Ari Rantalainen. Oh, sorry, couple of practicalities at the beginning. As it was already mentioned, this session will be recorded. We'll hold some time for questions at the end. So if you have any questions during the presentation, just post them via chat and someone might already answer them quickly, or then we'll cover those in the Q&A at the end. So I am Ari Rantalainen. I'm coming from, I work as a solution architect at Nordcloud. I already have, let's say, 12 years of the SaaS experience running a small, a bit larger software product for the last 12 years. Prior to joining Nordcloud, I was in roles of product manager, head of operations, head of product, and head of the R&D. Had multiple roles, but was able to see SaaS experiences from multiple fronts. So since that, joined Nordcloud and have been here for the past 4 years. Oops, sorry. I've been here for the past 4 years and working solely to get to know cloud better and to work on AWS with multiple customers in my portfolio to build solutions for them. So that's about me and about Nordcloud. We are a previously Finnish consulting company and recently been acquired by IBM, which has given us a tremendous boost in terms of moving into the cloud. Our aim is to supercharge our customers using the world's best technology platforms. So we are talking about these public clouds like AWS. We want to deliver our cloud services the native way, the way it's meant to be done. So it actually has the impact that we want, and it also the way that the cloud vendors want, and the way that the industry sees the best solution to be, so that we actually make a proper change in the value provided. We work in Europe at present, spreading out from the northern parts into Central Europe. We work with cloud implementations, application development, the core where I'm from. We provide managed services, and we are trainer gold partners for all of these clouds and provide training for all of these clouds as well. So, basically all cloud needs, please feel free to turn to us. We have more than 1,000 people waiting to help you guys if you need some help. And especially for SaaS customer base, we are currently offering this small hypergrowth program, which is 1 day of 1 hour of general diagnostics on what is your software platform, how it works, and if we can provide the solution, or how we can provide the cloud solution to you better, building a roadmap for you guys, and then helping to execute on these specific domains. If you're interested in more in that, please go and check that URL at the bottom, www.nordcloud.com/hypergrowth-AWS. But that's it for the sales pitch side, and let's move on to the real content of this discussion or session. So we're talking about microservices, decomposition, and design within the context of SaaS. So first of all, just to set the stage, microservices, they are basically a piece of software that is autonomous, works by itself, has one reason or one responsibility, basically, which can be large or small, hopefully small. It owns all of its data and can be deployed, versioned, and everything by itself. It's also isolated enough that you can work with it. You can have it working as a large entity or a small entity. It scales, and you have set APIs to access it, be it command line interfaces or be it REST endpoints or GraphQL, whatever. And in this diagram, we are showing a couple of samples of a REST API contract that you can have for that service. And it's operated and developed by a team that really owns it. So this is how we in this discussion or this session talk about microservices. So for SaaS, why microservices? But they are the thing to go for. They are a good solution. Small services that are independent and have their contracts, the API set. You are able to work with them as you please inside. You are able to, if they are small, you are able to change. You are able to change their direction as well. They are just agile. It gives your business the agility it needs. The small deployments, they make your life easier in terms of building those, configuring those, resolving problems, and of course all the blast radius that there is, so that you know that one service doesn't bring down the entire service that you have. Since they are small and can be scaled independently, optimizing the consumption results in cost savings. You don't over-provision, you don't under-provision. Even in cases where if you are able to leave the provisioning to the cloud vendors themselves, so AWS does a very good job in figuring out when you need to scale and up and down if you go for serverless approaches, as was discussed last week. Microservices give you a good fine-grained DevOps responsibilities or capabilities. It gives you the possibility of deployment, version control, all this independent deployability gives you red-green deployments or canary deployments, all that's enabled that way. And of course, you are able to manage via those DevOps practices, and you're able to take a look at that. You are not causing the service to go down, even if one of the microservices go down. So giving you more granularity in terms of management. And all that sort of builds back in that you can focus on the actual thing that you do the best. It's probably not going to be infrastructure management, server patching, and security. So in those cases, the area where you understand the best, you can focus on that and keep on developing your service and providing that service which you are being paid for. So if we think about microservice deployments or microservice architectures in general, this is sort of non-SaaS microservice model, but you can think of it this could be your SaaS microservice model as well, but then it means that you are deploying your software every time fully for each customer of yours, which is of course one approach, but it doesn't scale that well, and it causes you quite a lot of maintenance headache. But this is one way that you could be doing your deployments. You have a lot of microservices. They are fully isolated from each other service, but your customers would be fully isolated as well in a siloed form as it's usually referred as. You know how each microservice works. You are able to predict that. No one is cross-affecting each other. So one customer environment breaks, every other customer environment works as planned. So this sort of gives you simplicity in terms of running, but then in terms of development, or this gives you the confidence in running, but it gives you more headaches in operations and development. So what actually you want to go in terms of microservice or in terms of your solution architecture is that you want to have shared resources as far as it's possible to go. You want to minimize the parts of your service that are independent of each other, that are specifically built just for that one customer. So then we are talking about shared microservices or pooled microservices, which then are sharing some of their resources, not usually the data planes, but they're sharing compute, they're sharing the network, they're sharing some of the services that are out there. So this causes some problems, of course. It means that if there's one tenant that actually uses a lot of those resources, you're running into problems with the other tenants. So you are having these noisy neighbor problems. You can't really say with one customer, it would be easy to anticipate that, okay, during Mondays, there's a lot of usage, so we can scale on Mondays, scale the system up, and then scale it back down for the rest of the week. But with a pooled service, you don't really know what's going to happen there. You have problems in seeing that the tenant's data is separated from each other, so that tenant 2 is not able to access the data of tenant 1. So you have to think about really hard on this, especially when you think about compliance issues. But they are usually in the services that you are providing to your customers, there's bound to be some critical secret data that no one wants to share with anyone else. So that you need to isolate properly. And then there's always new tenants coming in and going. So increasing that load, adding that unpredictability. And of course, if something goes down, it goes down for everyone. So there are some problems in terms of pooling all your solutions. Well, not problems, but challenges in terms that they are something that you can architect and you can design around. So how do you then start splitting your services, your microservices in general? So normally you would start on, let's say, the most common case that people start when they start to think about their problem domain, and they start to think about how would I split this up into services, is that they start to track nouns in their specifications. So they go through the requirements and specs and find nouns like product, customer, order, ratings. They build services based on those, and that's not a bad approach. So you come up with the product microservice, order microservice, etc. This is sort of the customer view on things. This is how they see the problem domain, and therefore this is something that usually, especially if you read blogs and books about how to design and how to partition your services, you'll see this approach often. And it is a valid approach, but it doesn't take into account then the SaaS-specific problems. It doesn't think about if you have multiple of these running, or if you are using these for multiple customers, how is the consumption? What happens if there's a fault? What happens if someone hijacks or basically uses a lot of one service? What happens to the other tenants? How do you take care of batch operations and bottlenecks? So there is something to improve here. So SaaS is basically, if you think about the problems that were presented on the last slide, so those problems are on top of the other problems that you already have. So modeling, you should still go by the sort of traditional documented ways of defining your services, splitting those up and defining those domains, and DDD, domain-driven design, or event storming, excellent ways of getting there. But then you always have to overlay that with these SaaS concerns. So think about how those other problems can be solved within and on top of your microservice deployments. So a couple of those key areas or key problems that you have to think about when you do design your architecture for SaaS. You have to think about the tenant isolation. So to keeping those, especially the data, but other operations of different tenants away from each other. You should be thinking about large operations, imports, exports, big batch runs that will require a lot of resources for anything, video conversion, extra access to outside resources that require long wait times, everything there. So the fault isolation, what happens if something breaks? How does that affect everyone, or doesn't it? You have to think about how do you partition your data. So what do you put where, and how they are accessed, and how they are protected. And then, of course, one of those key things here is to think about the service levels that you're providing. So the tiering, the metrics, and how everything is being served, and how someone can buy some extra capacity or better service through those advancements in the tiers. So thinking about the tenancy, the first point in the last slide, so the tenancy isolation. If we think about the microservice model that you've already built by this point, you are looking at, in this case, we are looking at the order data domain. So first of those nouns that we had in some slides ago. And within that order data domain, we have a couple of concepts of order data and fulfillment data. So we can start thinking about the importance of each. Order data most likely is something that is very, very critical to your customers, and critical that they are not shared between other customers. There are multiple ways of decoupling these, but the most sure way to do this is then that you would have the order data as separate services or separate data boundaries. So what you can do here, that if you have, since you have the model that you want to have a separate order data domain or microservice, you then split that into two pieces. You identify that the order data is very critical. It is something that you have to have a separate, which might be coming from compliancy reasons, like if we're talking about the banking sector. But then some data, like in this an example, the fulfillment data is something that can be shared. You are building more operational work for you, for maintenance work and for operations by building silos. So you try to minimize the amount of silos that you build. And in this case, you just extract those pieces which have to be extracted. And the rest you build as a pooled service, something where everyone uses that same data. So basically, whenever you see that there is a requirement, it has to be split. Then you find ways to minimize that split, but split it and get one microservice in your original domain model to be two microservices where it requires, just to keep the tenants isolated. And then you have to think about how do you deploy those. You have a bunch of microservices for different tenancies. You deploy those separately, then from the pooled ones. So you also these decomposition is then driven by deployment or vice versa, where you have to think about where do you put what running and how. So basically think about, do you need to have a silo to protect the data, or could it be pooled? And basically every time you want to have it as pooled as possible so that you are keeping your maintenance and development overheads to the minimum. So then the next big category is bulk executions. So here we have a microservice. It could be the same order book, or it could be a product inventory or something else. So we're talking about noisy neighbors where basically one tenant then pulls all the data or pulls all the resources from from the others by executing something large. So in this case, for example, if tenant 3 would be to import a large video library that all those videos need to be converted into some specific formats with sizes, it is quite likely that it will be then eating up all those conversion resources from other tenants who then might want to have one small video here and there to be converted as well. So they'll have to wait until the tenant 3's large thing is either fully completed or there's a break somehow in the middle, and or there's a turn for other people. So it impacts your SLAs most probably, and the full experience that the tenants 1 and 2 will be wondering, why is my data not getting through as quickly as it normally does. So in that case, how about separating those services fully independent? You'll have those basic services for in the previous diagram for tenants 1 and 2. They would be as a joint service, but then you have for these large bulk operations, you'll have a separate service that'll take care of those things. You get to isolate them from each other. They are basically siloing once again, and there you can manage how the resources are spent within that bulk service. And the expectations of your customers is most likely, if they see that, or if you refer to them that this is something that can take some time, they are most likely quite fine with that, because they know that I just dumped a huge load of data in there and it takes time to process that. And you can throttle it in order to manage the cost that the bulk operations take during that processing. So going for the next topic, the fault tolerance part. We have services that basically, out of those microservices, you build your service, your SaaS offering. It will have some critical parts and it will have some non-critical parts. Quite common example here is we are talking about streaming services that provide you with access to movies, but also provide you that since you like this movie, you'll most probably like this movie as well. So that movie, providing those movies and doing financials there, those would be your movie manager and account manager services which are the most critical. But if some cases when you want to go and see the latest movie, you're not getting ratings from other people, other viewers, or you're not getting suggestions out of the service, you're still able to do your core work, but you are not getting that bonus content or added benefit from that platform. So in those cases, those services, if they go down, they're not going to bring the entire system down. But if you start building as a huge monolith your service, there are places where secondary or tertiary or even further removed services could basically bring down the entire service. So if you keep them isolated and think about as well as the other levels, you think about these in levels of criticality of your service, then that's one way that you have to start thinking about sort of, well, how do you split those microservices from each other? How do you decouple that system that you might already be running on your own environments or have been considering, but how do you break it down into smaller services? So thinking about that blast radius that has been mentioned, what does it impact? And can it be just fully gotten rid of? So also building for those critical services, the mechanisms that if they are not getting answers from those other services, not so important services, how do they cope with that? That they have to cope with that. They have to be fine with that, so that the core service that you're providing is being fulfilled. And then you have to start thinking about how do you partition the data, or then the data partitioning is one of those things that will impact your service decomposition. Even though that some services or some data is very close to each other, it doesn't have to live in the same place. So this gives you once more one added flexibility of putting things in different places, trying to pool some data or some accesses, and having those silos only when you have to. So you have to think about what data has the criticality that it needs to be isolated. But then also, you can also see here that what data needs to be backed up, and how do you want to do those. In some services, you might have daily backups. Some cases you have to every changed backups, or in some cases you're fine, and on some of your service level, it's just fine that you have only monthly backups. And also then you're talking about quickly about the amount of resources that you provide. So the provisioning of your service, the database instance that you're running, all that influence how you decompose your service into those microservices, and it gives you that flexibility that you want to think about as you approach how would you like to build this. And then, as said, your tiering. You will have most likely at least some different tiers of your service. So then you want to think about also that if these parts of the service are being offered on a quick response or more beneficial or more wide service or more features, you'll want to manage that somehow. Would there be a premium version of the one microservice versus a basic version of it, or how does those execution paths go along? So that also drives to think about how those microservices are there, and what do you put where, and how do you put it there. So as a simple example, in terms of tiering, you'll have basic tier tenants that they may have very different use cases compared to the premium tier ones. If they do, it's easy to sort of notice that, okay, this company, the basic ones are using this as initially intended, let's say, as a product manager microservice. This is something that you identified in your requirements gathering. They use mostly the get product calls in order to get those details and then manage the inventory just a small bit. But then the premium tenants use it for different services where they just read it only a bit, but actually are maintaining it a lot in order to get the value that they want from the system. So there, you initially probably would start, at least on your design, to have this single product manager microservice, and there, either by identifying additional requirements coming from feedback from customers, or by usage, you'll notice that it's actually being used for multiple reasons, and you are able then to extract two services out of that and provide the other one for the higher tier service, and to see that then it provides better capabilities for the premium or pro level customers. So once again, one thing to think about when you are talking about how do you decompose your service into microservices. So then going into thinking about how do you want to proceed with this. As said, there are multiple approaches, but the two main ones is that, of course, you think a lot in advance. You analyze the market, you analyze the system, you analyze the need, You analyze your customers, and on paper already, as you are defining the system, you are already defining those microservices. It usually is the slightly longer way, and it is usually referred as the waterfall service or waterfall method of developing. But it can be in some cases where you have very, very well defined problem domains. It can be something that is beneficial, at least to some extent. But usually good enough is good enough, and building your service in a first attempt and start to iterate from that. So build your microservices as you see that they would be working, with keeping all that in mind that was already mentioned in these discussions. But then, as the usage grows, you start to think about your monitoring needs, or you refer to your monitoring, you refer to your metrics, you notice how different systems are being used in different ways, and you split it up in order to support the usage or your operations, or both, or even future development that you are planning. And once you come to that and you see the data coming in, you might split it again. So usually it's a good idea to start with something that is easy to understand, maybe build something slightly bigger, and then start to break it apart. And as I'm referring here, earn its way out. So once it's showing that it's actually being requested a lot, or requires the expansion, requires separation, then do that. It's usually not good, it's usually quite unnecessary to define future too far ahead. Just deal with the problems that you have today, because, well, you don't know if the future predictions will be fulfilled. They are just usually predictions. So then, key takeaways from these topics that I have covered already. So thinking about how do you want to deploy your solution? How are you requiring to isolate your data, your services, your customers, your tenants from each other? That will most likely have an impact on how do you decompose your service into those microservices. Do not make the assumption that data needs to live next to each other, even though it has relations to each other. Be open to have that as one of those areas where you can build your service, which gives you flexibility. Data can live here and there, but do keep it as the private ownership of that microservice, so that you are not cross-accessing data, but you are keeping it within that microservices. Otherwise, you are heading into dangerous territories. So think about also your tiers, your service levels, and as you design. So think about how what kind of service you're providing, what kind of usage, how that usage differs from tenant to tenant, and keep that, or your service level, keep that in your mind as you do that decomposition. Fault tolerance, well, everything's going to break all the time. That's the basic motto that you have to keep in your mind as you build systems. But then you have to be prepared for that. So be prepared for faults to happen, things to break. And think about what is the impact of an error here, what is the impact of an error there, and how do you then mitigate it, and how are you prepared to deal with that. So try to see those different service importances or criticalities, and try to manage then which service that it's fine to die, and just to keep it so that it doesn't affect anything else. So have those fallbacks in the other service that if something is not available, they'll still manage. Track your system. Look at who's using what kind of queries are being executed, what kind of things are being accessed all the time. And then you'll find out those peaks where you have to go and start to duplicate or extract your code and start to build separate services out of your current service. And this sort of also to keep in mind that do not be afraid of repeating your data here and there. Maybe falling back to the second bullet point, that as you're building those microservices, we usually have this first normal form of data in the mind that one data needs to live only in one place and it should not be replicated. But with microservices, just remember that the services themselves have to own their data. So if they need that data, you should copy that data around and just take care that all the services have the right data that they need. And to support, so you're getting metrics out of your system and do your decomposition for that. And start with larger services, and only once you see that you are required to decompose these, then start building those apart. Treat your development efforts not as once only efforts, but something that's organically growing all the time. Be prepared for change, and be prepared to change your service decomposition, slightly tweak it, and so that it adjusts to the needs that your customers have. Keep that agility in mind. So, and as it says here, keep that decomposition hat on your head every now and then. Do not go too deep into the thinking about what would be the best solution, how this should be done. If you read all the related documentation and books on the topic, they'll come to one conclusion that this is how it should be. That's not going to happen. There's always multiple ways to approach this, and there's always going to be slightly better way of approaching it and optimizing your solution. But do not overanalyze, do not over-optimize too early on in the system. Once you have hit sort of the very stable state and you are able to say that this service is being used in this specific way over many tenants and over many days or months, then you'll be able to start to optimize and say, okay, fine, now this we know what this does and we know how to optimize its cost and impact and performance. And then think about the silos of your customers' usage, where you want to pull those the system to be isolated as its own, or where do you want to have those pools of usage. So think about those multi-tenancies. Where do you want to have just a key being telling you, or one data point in the database on that row telling you that this belongs to this and this customer? Or is it that the entire table or even the entire database is isolated to your one specific customer? The former direction gives you less of maintenance overhead, but gives you more risk that your query into that data forgets to use the tenancy key, and then you are providing that data to your other customers that shouldn't be seeing that. And that erodes the trust very quickly, and you will be having some hard discussions with your customers pretty soon after that. So keep those workloads and think as you think about the multi-tenancies or single tenancies, silos or pools, keep those in mind as you do your decomposition.